Our next presentation, this morning's session, is entitled Peanut Response to Vegetative Injury Occurring at Different Intensities and Growth Stages. And our presenter is Hayden Godwin.
Thank you for the introduction, Dr. Kimmerod. Like you said, my name is Hayden Godwin, and today I'll be talking about peanut plant response to vegetative injury occurring at different intensity and stages of growth. Physical injury of crops can occur from a variety of sources, such as hailstorm damage or animal feeding, such as deer feeding on crops, movement of animals such as hogs or other vermin or objects through the crop, such as equipment. It's important to be able to recognize this physical damage on peanut for subsequent management decisions. And our hypothesis is that higher intensity yield at later growth stages will not result in greater yield loss. Some of our objectives in this study are to assess yield loss based on injury timing and intensity, quantify differences in Normalized Difference Vegetation Index, which will henceforth be referred to as NDVI, between non-treated plants and injured plants over time, and also to quantify digging losses from different timing and intensity of physical damage to peanut as influenced by injury timing and intensity. We planted Georgia 06G seed into at 19.7 seed per meter in Tifton, Georgia in 2018 and 2019. Experimental design was a randomized complete block consisting of 4 reps with a factorial of injury timing and intensity. Statistics were analyzed using PROC Glimmics and SAS version 9.4 with mean separation pairwise t-tests. Injury treatments were applied 4 different stages throughout the season at 30, 60, 90, and 120 days after planting at 3 different intensities of 33, 66, and 99%. A non-treated check was also included and replicated. These pictures at the bottom of your screen on the left is our 33% damage treatment at 30 days. In the middle is our 66% damage, and on the right is 99% damage. To simulate the physical injury, we used a gas-powered weed trimmer with flexible rubber impact points turned to a wide angle. And when you turn the weed eater up to kind of on its side to a vertical angle, you get more of a slapping kind of motion, and that's the best way we saw fit to simulate the hail damage. And 2 different types of damage that we were really trying to simulate in this trial. One, if you direct your attention to the bottom right image, you will have some severing of vines and also some just rupturing of vines without completely detaching them, and seeing how they recover from that. Digging losses were measured post-harvest in a 1.83 by 1.83 meter to a 15 centimeter depth, and NDVI was recorded 11 days after each treatment using a crop circle active light sensor. For the next few series of pictures, the picture on your left will be the day after treatment was applied, and the picture on your right will be the day before digging at the end of the season. So here at the 30-day after planting treatment at 66% damage, you see a good vegetative response. They're able to grow back and lap by the end of the season. At 99% damage, you also see a good response from the foliage, and that the plants were able to survive and put on foliage by the end of the season. At 60 days after planting, the 66% damage, you see less of a response, and plants don't put on quite as much foliage, but still are able to put some vegetative matter back on. Similar story with the 99% damage at the same timing. The plants are still able to put it back on, but just not as much compared to the earlier timings because they didn't have as much time to recover by the end of the season. At 90 days after planting, these pictures are going to start looking a lot more similar. That's because there's less vegetative matter that was put back on by the plants by the end of the season. Same story here at the 90-day after planting at 99% damage level. There is a minor response, and they're able to recover a little bit and put on a little bit of green matter at the end of the season, but very little compared to earlier timings. And at 120 days after planting, you see almost no response and no vegetative matter put back on. that's I would think that at this time in the season, it's the nutrients are going a lot more to the sink, to the reproductive parts of the plant, instead of trying to put on vegetative matter. And this is a multispectral image that was taken mid-season. I've highlighted a non-treated check for you to be able to refer back to. And the box that just popped up on the right is a 33% damage. So you can see there's a lot less vegetative matter compared to the non-treated check, but still more than the 66% damage level. And moving to the 99% damage level, there's almost no green there to see. And these next couple of graphs are our NDVI data that we got from using our crop circle. This is for the 30-day after planting treatments. The box that just popped up on the left is 11 days after that treatment was applied. And you can see they're all much different from each other. And by the end of the season, they're all equal to the non-treated check. For the 60-day after planting treatments, there's still, right after treatment, they're different from each other. But by the end of the season, the 33 and 66% injury were able to recover to be equal to the non-treated check, and 99% injury was not. At 90 days after planting, you kind of like what you saw in the pictures earlier. There's not much of a response by the end of the season, and these two sets of graphs that are 30 days apart still look very similar as far as distribution. And at 120 days after planting, you can see the difference in the treatments there in NDVI. Moving into our digging losses section, the main three that I want to focus in on are the only three that were significantly different than any of the other treatments. These are our later and more severe treatments. And my hypothesis on why the digging losses occurred was that when the physical damage was sustained that late in the season, it deteriorated the strength of the pegs and they weren't able to hold on to the plant when the plant was inverted, or also just the injury caused stress to the plant and led to the plant aborting a good bit of the pods. Moving into yield, you can see there's kind of a stair step between each of the timings. So all of the red are 30 days after planting treatments, all of the green are 60, and orange is 90, and yellow is 120. So they're grouped together based on timing. And you can always see that the 33% yielded significantly higher than 66 and also 99%. And one thing I really want to focus on is the 90-day after planting treatments where we saw our lowest yields. My hypothesis behind that would be that the 120-day after planting treatments they already had, more total cell mature kernels. They were more filled out, had larger seed. So they were able to still have a little bit higher of a yield compared to the 90, but 90 day after planting at any injury level is where we saw our greatest yield loss. So just to summarize, we were able to reject the null hypothesis. Yield loss increased with greater intensity at later growth stages. 90 day after planting treatments had the greatest yield loss at each injury intensity. Vegetation recovered better after earlier timings of damage, regardless of injury intensity, as confirmed by NDVI values. And also, digging losses were greater for later injury timings, coupled with greater injury intensity. Some of our ideas for future research: we want to try to determine optimal digging dates for delayed peanut maturity based on timing of physical damage. I wasn't able to include it in this presentation, but some of the earlier treatments, like our 30-day after planting treatments, had delayed maturity and needed to be pushed back compared to other timings of treatment. And we're going to have to do some economic analyses and it's also going to require additional year replicates to determine whether crop management, continuing inputs is feasible or not worth continued input cost, or even worth digging or harvesting and the costs that are associated with that, if it's even worth that. And also to assess differences between continued management of minor injury versus just replanting the entire field if it happens early enough in the year to still be feasible to replant the entire field. This time I'd like to acknowledge our technician, Zach Cromer, and fellow graduate students and student workers for Dr. Tubbs, Dr. Pilon, Dr. Montfort, and Dr. Porter crews at UGA. Also the UGA Lang Rigdon Farm staff in Tifton, Georgia. And a special thank you to the National Crop Insurance Services who really played a big key in getting this trial and study off the ground. And they do a lot for this trial, and also the Georgia Crop Improvement Association, who make it possible for us to do our research. At this time, I'll take any questions or comments or discussion, and I would also like to thank you for your attention.
All right, thank you for that presentation. We have several questions for you.
All right.
The first question is, have you tried quantifying the damage? This is from Simmerjeet Verk. Have you tried quantifying the damage by measuring force applied, angle of impact, etc., to quantify if better into different damage types?
Okay, so the question was, have we quantified our injury levels over different damage types? And so we have three different methods that we try to quantify how close we're getting to what we're aiming for. The first one, for every timing that we go out there and apply treatments, we measure the amount of time it takes us in seconds to achieve the 99% damage level. And then we factor that out into 66% of that time and 33% of that time. And that's just the amount of time that we should spend on each row that we do at a time. And also, we take quadrat pictures and look at them with ImageJ software, and they give us a good feedback of how accurate our damage application is. And also we take biomass samples of vegetative matter 7 days after every treatment is applied.
Okay, excellent. I believe that concludes the questions we have. Thank you for your presentation, and we'll move to the next presentation.
All right, thank you.